Okay, so to get started, I'm going to backtrack a little bit to not quite the very beginning, but to some stuff we did in Lab 1. And so I'm going to go over that. So I'm actually working in RStudio today, so it should look, if you've got a Windows computer, it should look almost exactly like this. If you have a Mac computer, you won't see this menu unless you push your mouse up to the top of the screen for this menu to show up. So this is, I'm going to start by leaving this project and going to a different one. So I'm just going to go to something else I'm working on so that I can demonstrate how to get into, if you successfully cloned the GitHub repository. If you got to that point in the lab 0 successfully, then I'm going to show you what you need to do from here. This is going to take just a second. Okay, there we go. So wherever you are in RStudio, if you successfully cloned that GitHub repository, when you start up, you can go to the File menu, and you should see this area that's Projects. And so File menu is just the menu under the word File here. Don't confuse that with this. Don't confuse that with this. This is actually your files, but this is the File menu. In the File menu, one of the sections has Open Project in New Session, and Recent Projects. So you're going to come out here and look for Recent Projects. You're going to look for the one that has just this, the name of the class and Spring 2026, or the POLS 3316 Spring 2026. You find that, click on it. It will take you to that project. And if you have a fast computer, it may be faster than this. Mine is pretty fast, but I have a lot of stuff on the drive, so it slows it down a little bit. But it will be there in just a moment. Okay, so now we're there. So the next thing you're going to want to do, especially if you haven't done this yet, is you want to come over here to the Git area in the environment, and you want to do a pull, which is the green down arrow. If you have it compacted, you'll just see the arrow. But if you have it like this, you can actually see the word pull. If you haven't done this yet, you should see some stuff happening here. I've done it, so I've got already up to date. But you should see it doing some things, and that's fine. It should do everything it's supposed to do. It should pull down the latest updates, the things that I've added. And so now we're going to go down to the files, not the file menu, but the files over here in the lower right. And at this point, you should have something that shows labs. If you click on that, and then click on lab 1, there should be a file in there that shows lab_1.r. And if you open that by clicking on it, it'll pop up open over here in the left top part of the screen. This is all assuming that you haven't modified the setup, but if you've modified the setup, I'm going to assume that you knew what you were doing. So this is just the default setup. So you come over here to the left top, and there's a lot of code. All you need to do is click in that and click maybe. All right. You want to select all. So there are two ways you can do that. One is to highlight with your mouse and highlight absolutely everything. The other is you can hit Control A on Windows, or I think Command A on a Mac. Once you've done that, you want to run everything. That's this button right here. You want to run the entire thing, and it will do some things. You'll see some things happen down here. You don't need to worry about that too much unless you see a lot of errors happening. And if you have a lot of errors happening, then we need to talk about your setup. But you shouldn't see a lot of errors because this is pretty straightforward. And I've run it. I've like triple checked it. So it should do what it needs to do. The reason we just did that is because the last stage of lab 1 was to create some data. And so if you got errors when you were trying to type lab 1 and you didn't get to that point, or it didn't go to the right place, you can't do lab 2. So, but you can now. You should be able to. So the next thing we're going to do is I want to have you come over here to edit, the edit menu, which is right next to file. And almost at the bottom is clear console. So I want you to click on that. And it does just what it sounds like. It clears everything out of the console. The reason for that is when we get to the end of this lab, I want you to be able to send me your results, just like we've done before, including any errors you may have had or whatever, and we'll be able to work from there. Now, what I'm about to do, you don't need to do. I'm just opening up. You can do this from Canvas or you can do it from here, but there's a lab instruction document, and I'm going to actually walk through it. I'm going to walk through it alongside you, so you need to open it up. It is actually in the labs folder. It's the lab2.docx, but it's also in Canvas. So you can get it either place, and it's a Microsoft Word document. And so from here, we're going to work through lab 2, just like this. So the first thing I said, be sure you're in the project for the class GitHub repo. That was the very first thing we did, where I went to File, Recent Projects, and clicked on this. If you didn't already do that, go ahead and do it. The next thing is, I'm sorry, I'm going to close down a couple of tabs just to make my screen cleaner. Okay, so if you, the next thing we're going to do is I'm going to show you what if you can't open it that way. So another option to open a project is you can go to File, Open Project, and then find the project on your computer. So it's not going to be in the same place. I have my computer set up where I have them, I have my projects, I know where they are. You have to know where it is to do this one. So you have to know where you put your project. But you go to whatever folder the project is in and look for this file that has .R PROJ in the file extension. So this thing after the dot, in front of the dot is called the file name. After the dot is called the file extension. You're looking for a project file, which is what this is. And so to designate it as a project file, they name it .rproj. So that's what you're looking for. You click on that, it will do the same thing as going to recent projects and finding the project there. So the next thing we're going to do after that, we're going to clear the console and remove all the objects. I already had you do that, but why not? We'll do it again. Go to the edit menu and hit clear console. You can also do that by using Control L or Command L. The next thing we're going to do is make sure there's nothing in the environment. There are two ways to do this. One is you come over here, you need to be in the environment tab. And look at that. Sure enough, I had stuff in the environment. You can click the little broom. That's one way. And that will clear everything out. The other way is you can type this command that I can never remember. rm list equals ls parentheses empty parentheses. So it's rm open parentheses list equals ls open parentheses close parentheses, and basically that empty parentheses after the ls tells it to remove everything. So it does the same thing as the broom. Next thing we're going to do, again, I had you already do this, but we're going to get in the habit of doing this at the beginning of every lab, is come to the Git tab and click the green arrow to do a pull. And since you just did it, yours should show already up to date. If it doesn't show already up to date, write down what it says, type it, write it, copy and paste it, however you need to do it, but figure out what it says, and we will discuss that. You can also type in the console. To do it. Does the same thing, should return the same thing, should be already up to date. If you do it this way and you get an error, it's real easy to highlight that and send me a copy. In fact, if you do it that way and it shows the error, then at the end of the lab, when you copy everything, I'll get it. You can just make a note in the comments to make sure I don't miss it, that yes, you had an error. So the next thing we're going to do is make a new script to put the file in. And so you can do that by clicking here or by going to the File menu and clicking New File, R script. You'll notice the file doesn't have any name. And we want to, the first thing I want to do, or the first thing I'm in the habit of doing, is saving the file and giving it a name. So in this case, this is lab 2. So I'm going to save it in, I suggested you make a folder called My Labs to keep your own work in. That's what I'm going to do. That's what I did. And I'm going to give it the name lab2r. Actually, I am going to change the name on my, I'm not going to use that name on my computer because if I use that name, it's going to interfere with yours. So I'm going to name mine Tom's Labs. And you're free to look at these anytime, but don't save anything to them because you want to save to one that has a unique name for you. So I created a folder. If you want to create a folder, you can either use your name or you can put My Labs or however you want to do it. And I'm going to save this now. So all I did was create the folder. Now I'm going to save the file to that folder, and I'm going to name it lab, maybe if I can type. I'm going to name it lab_2.r. You can name it something else if you want. But the closer you are to naming it that, the easier it is if we're all on the same page. So, and save it. There's nothing in it yet, but now it's saved. And now anytime that I do a little bit of work, I can come up here and click one of these little square things. The square disks, they don't look like disks. They're not round, but trust me, that's what they are. I can come up here and click any of these to save my work as I go. So the first thing we're going to do is load that data that we saved at the end of the last lab. So that script that I had you run, from lab 1 should have saved this. And just in case it didn't work right, I also put a copy there so that the data should be there for you. We're going to use a function called read.csv. This is actually not the best one to use, but it's the base one. It's the one that everybody has as soon as you install R and RStudio. It is built in. There are better ways later on. There's a different function. We'll get to that probably next time or the time after. But for now, this one will work perfectly fine for this little data file. So what we're going to do is I'm going to create an object named my data columns by typing in the script my underscore data underscore columns. And be careful if you make a typo, like I just almost put in a plus sign instead of an underscore. If you do that, you have to type it the exact same way the rest of the time, because whatever you name it is what it's going to be named. So if you make a typo, the typo sticks. Okay, so I'm going to my data columns, and the next thing is read CSV. That's the function. And then I need to tell it where to find the data. And the data is in the data directory, and the data is named my data columns.csv. So that's what I'm doing here. I want data, my data columns.csv. And again, you have to type this exactly. If I put a different letter in here, or I leave out the underscore and it doesn't match this, computer's going to have no idea where to find it. The computer cannot figure out what I did. It'll return an error, and it will help me to find what the problem is, but it can't figure out on its own where to find it. So I type it, the data tells it, the data with the slash, that word data, tells it to go to this directory. I have some other things in this directory, so if I put assets slash, it would come look in this directory, and it wouldn't find it because it's not there. So I have to send it to the right place, and then I have to give it the right file name. At this point, it hasn't done anything yet. Nothing has appeared out here in the environment. Why not? Because I haven't run it. So I'm going to highlight that and hit run. And if everything worked, it should have created this object out here. My data columns is the name of it. I'm going to expand this so you can read it. My data columns is the name of it. 5 observations of 3 variables. Slide that back over. I'm going to go ahead and save my work just because I'm obsessive about that. Now we want to view the data to make sure that it works. We can do this a couple of ways. So one way is click on it, but you don't really want to get in the habit. I mean, I don't want to say you don't want to get in the habit of doing it. That's the easy way. But if you're writing a script, you actually want to have everything in the script to do the things you're doing. That's the whole point of doing this, is to have it where it will be repeatable. You can come back and do the same thing without having to click all over the place. You can come back and have the entire thing run the way that I did with that lab 1 script. Just highlight it and click run. That's the point. So view the data. We're going to use the view command. And R is case sensitive. Uppercase and lowercase are different. Capital letters are different than lowercase letters. View is one of the very few commands in R, or functions in R, that starts with a capital letter. So it's capital V, I-E-W, and then you have to tell it what you want to view. And what I want to view is this thing that's named my data columns. And so one of the reasons we use RStudio is because it knows what's out in the environment, everything. It knows all of the packages we have loaded, all of the libraries that we have loaded to help us do things. It knows all the data that we've loaded. It knows all the function names, and it knows how they work together. So I started typing my data columns, and this popped up like this, fully spelled out, correctly spelled, no typos, and all I've got to do is click on it and it'll fill the rest in for me. That's really important if you have things where, especially if you have fingers like mine that tend to hit the wrong key, that can be really valuable because you're not going to get a typo that way. So now we're going to go ahead and view this. And so this is that data that we created in lab 1 by creating the first vector, the second vector, and then we created the fourth vector, because if you'll remember, the third vector only had 3 variables, or only had 3 observations of the variable. And so it was not the same length. So we ended up creating the fourth one, and we put them all in column format, with the vectors being columns. So we just loaded, and so this is another of the points. That work that we did in lab 1, it's saved. We don't have to do that again. So yeah, if all you want to do is find the mean of 5 numbers, yeah, you could do that with a calculator quicker than you can type out an R script to do it. But if you save those numbers and save the function and you save everything, you can reuse it and it will be there. Now this Copilot thinks that what we're going to do next is find the means and medians of each column. Let's find out. I don't think that's what we're going to do. Yeah, that's not what we're going to do. Well, it is. Let's see. Yeah, we are, but we're going to do it in a way that we can create a table. And so we're going to use the apply command. This is what we did last time, but we're going to go ahead and redo it because we're going to get the mean, we're going to get the median, but then we're also going to add the variance of the standard deviation. So to start with, we're creating a new object with the very cumbersome name column means columns. I named it that because we're finding the column means from this data that's called my data columns. And so now that I told it what I want to do, it actually knows what I want to do. We're going to use the apply command, and we're going to apply to, and so the next thing we're going to do, well, so this is the name, this is the assignment operator, where I tell it what I want to put in the thing I'm creating. This is the apply function, and what I'm going to apply to, the first thing I have to tell it is what object I'm applying this to. And what I'm applying it to is the object, this object that I created up here, my data columns. What am I applying? The second thing I have to tell it is, do I want to apply it to the columns or the rows? And rows are 1, columns are 2. So I want it to apply to the columns, and I want it to, and the function is the last thing I have to tell it. So I'm going to expand this so you can read everything. So here I'm creating an object. This is the assignment operator that tells it, okay, I'm creating this object. This is what I want you to put in it. This is the function just to apply something to something else. So it's just what it sounds like. And what I'm going to apply to is this thing up here. This thing that's up here that I created that's now over here in memory. So I'm telling it to apply to that thing. And then here I have to choose one or two. Do I want it to apply to the columns or the rows? And rows are ones, columns are twos. So I want it to apply to the columns. And what do I want to apply? I want to apply the mean function. The mean function is just what it sounds like. It's the function to find the mean of something. So now if I run that, it has created a vector named column means columns. It's numerical. It's got 3 things in it because there were 3 columns. So we have 3 means, and the means are 3, 8, and 13. So it's done that for us. The next thing we're going to do is I'm going to come back over here to this and make sure I'm not getting out of order. Here's a little more explanation. I just explained this, but if you want it in writing, the explanation is here. We're going to do this again, and we're going to do this with medians instead of means. So I'm coming back over here, and I'm going to do the exact same thing, except I'm going to name this column means. No, I'm not going to name it. I'm going to name it column medians columns. Everything else is going to be the same, except I'm replacing mean with median. So I name the object, assignment operator, use the function apply. I'm going to the same thing. I want it to apply to this. I still want it to apply to the columns. Instead of mean, I want it to find the median, and I'm set there. That's good. And I'm going to hit run. I can also just find the mean of a particular column by doing the mean function and the name of the data frame. This object out here is a data frame, the $ operator, and then the name of what I find the mean of, which is the columns or column 1. So I could do that. I can do it column by column. Maybe I can. Oh, no, I can't. That's not what I need. That's not the name of it. That's the problem. I let the AI fill it in, and the name of it is first vector. There we go. So the mean of column first vector, it's 3. So I can do that. That works. But we're trying to create a table ultimately that has the variance, standard deviation, mean, and median, all 4. So the next thing I want to do is I'm going to create a thing called column variance. I got lazy. Column variance. I'm going to name it that. I'm going to use that assignment operator to assign something, and then I'm going to use the same apply command. I'm applying it to the same data frame. I want to use, I still want it to be columns, which are 2. And then the function to find the variance is var. So the R function for finding the variance is var. So I'm going to do that. And I'm going to run that. And it has done its little trick, and it's out here, and it's found the variance of all the columns. And what do you know? The variances are all the same. You probably would guess that because all I did was go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They all have the same spread. So the variance should be the same. Save this. And now I'm going to create one called column Standard deviation. Nope, I'm not. I'm going to make sure that it matches what I've got over here. I'm going to, yeah, okay, column standard deviations. And so I'm creating an object with that name. I use the assignment operator to assign a value to it. And I'm going to use apply, still applying it to the same data frame. I still want it to apply to the columns, so I use 2 again. And then the function for standard deviation in R is just SD. And so I'm going to use SD. And so I can highlight that and run that. And you may have seen something happen out here. There it is at the top. And since the variances were all 2.5, the standard deviation, you'll remember, is the square root of the variance. The square root of 2.5 is 1.58. So with the same variance in each one, the square roots are also the same. So why did I create these things? Well, because what I want to do is create a table. And so what I'm going to do that is I'm going to use the dataFrame function to combine these things. So I'm going to, once again, create a object named statistics table. So I'm naming it that, and then I use the assignment operator, that left arrow hyphen, to tell it what I want to put in it. And I'm going to use the data frame function, which we did this last time, data frame function to tell it what I want to put in it. And I want to create, in this data frame, I want it to have mean that shows the column means, median that shows the column medians, variance shows the column variances. So these are going to be, my row names are going to be mean. Be careful, I don't want to. So mean equals column means. And then that's not right. That's not what I want. Yeah, it is. Column means columns. So I want the mean to show, the mean section to show this. So I got mean equals that. And then I want the median to show this. So I'm going to say median equals column medians columns. I got to be careful that I am typing everything. And variance, I want these to be capital letters. All right, variance equals, and I named that one a little different. I named it column variance. And then standard deviation equals column. Ooh, I put 2 underscores. That wasn't good. I made a typo up here. So I put 2 underscores. So I've got to put 2 underscores here or it won't work. Yeah, so I caught that, fortunately. So if I run this, it's created a data frame up here. And I know it's a data frame because it's up here in this data thing. Statistics, 3 observations of 4 variables. What are the 4 variables? The 4 variables are mean, median, variance, and standard deviation. And I've got 3 observations of each. So now I want to see that table I've created. I mean, really what I created was a data frame, but if I type in the name of it and hit run, it'll show up as a nice little table down here, and it'll have each of the columns from the original data frame as an observation, and it'll show the mean, median, variance, and standard deviation for each one. I'm going to pause for just a second. I'm going to check and see if we have any questions in the chat. Maybe. Okay. All right. I'm actually going to check my email because it doesn't look like anybody has joined. So I don't know if the link isn't working or if something else is going on. I guess you're all just looking forward to the recording. So I'm going to move on then. The next thing we're going to do is load some data a little different way. One of the ways that we can load data is by loading some of the stuff that's built into R. It has a lot of built-in data sets. And there are also packages you can load into R that also have data sets. So this one is called USA Arrests. It contains statistics by state about violent crimes in each of the 50 states in 1973. So our unit of observation is the state, and our variables, you'll see in just a minute. So you can actually work with this data directly without creating a data frame. But creating a data frame allows us to do some things, a little more simply. And it allows us to combine things in some ways. It's also just the way that I normally work, at least. So I'm going to load it into a data frame that I'm going to name arrests. And to do that, all I've got to do is type the name of the function to pull up that data. So when I do that, it pulls that data in and it puts it out here in my data frame with 50 observations, because there are 50 states, of 4 variables. So the next thing we want to do is see what those variables are and take a look at it. So we're going to do view, which remember has a capital V, arrests. You do view arrests, you highlight it and run it, and you'll see that the variables are 3 different crimes: murder, assault, and rape. And then the 4th variable is the urban population. So that's what % of the state live in cities. So, in Alaska, it's 48%. California, 91% of the population lives in cities. Down here, South Dakota, only 45%. Vermont, only 32% live in cities in Vermont. So this is urban population is potentially an X variable, something that we could say might cause crime to increase. More urban population, you might expect more crime. And so we could call this our X, and then murder, assault, rape might be our outcomes. It's also possible that if there are more assaults, there'll be more murders. Or if there are more, more of one crime might contribute to more of other crimes. There are lots of things we can do with this data now that we have it loaded. So viewing it is just the start. The next thing we're going to do with this data is I want to run a function just to list the names of the variables. And the names of the variables are the names of the columns. So I want to have that. And the reason I want to do this is because, and I can do that, is because then I have it down here in the console. It's handy. I mean, I can come over here and find them and I can type them, but I've got them right here where I can work with them now. So I know what I'm working with. And I'm going to save again because I'm obsessive that way. And so now I want to find, if I want to find the descriptive statistics for each of these variable names, so the the word file is missing the $ operator, so be careful of that. I don't know what happened there, but these are supposed to have $signs, all of these, and also these are separate lines. So if you copy and paste from the Word document, it's not going to work. What we need to do is, so we're gonna go through these in order, and I'm gonna do them. I want to do mean, arrests, and I want to type in each one of these column names. And so what I'm doing here is mean is the function, arrests is the name of the data frame. The $ tells it in that data frame what column to look for. So this tells it what data frame to look in. This tells it look in this column. So if I highlight that and hit run, it will give me the mean for each of those statistics. If I want, I'm not going to do all of these. I'm going to do just the one. I'm going to find the median, standard deviation, and variance of just one of the columns. For practice, you can go through and find the median of the others. So there's the median, the variance, the standard deviation. So before the next lab, try on your own to use that apply function the same way that we use the apply function up here. So you want to name the things different things, but use that apply function to create a table of the means, medians, variances, and standard deviations for each of the variables in the arrests data frame. Give it a try. See how far you get. If you get all the way to actually creating the table, there might be a little bit of a bonus. Even if you don't get all the way to creating a table, if you get part of the way, there'll be a few points. So try this on your own before the next lab, using this arrests data frame to create a table of the means, medians, variances, and standard deviations for all 4 of the variables. Next thing we want to do is, so we're done with that for now. The next thing we want to do is get some data from a web source. So this is something, and I don't do this one that often, but it is an interesting thing you can do. getting data directly from the web. I prefer to get it from the web one time if I have to and save it, because sometimes getting data from the web is a little bit slow. But Jenny Bryan, who is one of the people that is involved with our studio, with actually authoring stuff, helping put together our studio, and somebody who's a real expert on how to use our studio well, has this data set that she's created, called the Gapminder data set, and it looks at life expectancy and GDP by country. So it's something that, is kind of useful for us, at least for demonstration purposes. The first thing we have to do before we can do this, we need the tidyverse package in order to do this. Unless you have already done this, the first thing you're going to have to do is install the tidyverse package. And so to do that, you just need to type install packages. And if you start typing tidyverse, it's going to pop up. This is what you want, the tidyverse right here. If you want to type it out all the way, you have to put it in quotation marks. You're going to do that. You don't have to highlight it. If you do this in the console, because you only have to do it once. So you don't want it in your script. It's going to do a lot of stuff. It's going to take a little bit. You don't want to do it every single time you run this script. So you run it. It's going to do this. It was pretty quick on mine because I've already got it installed, and it went out and looked at it and realized that, so it didn't do anything. But it will probably take a minute. Some of your computers are probably still working on it. That's fine. You can, if you're watching this as a recording, you can pause it while that happens. Now, now every time that we want to use the tidyverse package that you just installed, we do have to load it though. So you only have to install it once, but you have to load it every time. And you do that with a different function, which is library tidyverse. And for some reason, the install function requires quotation marks. The library function does not. So we're going to put the library tidyverse in the script. Okay. And this brought up all these warnings. These are just warnings. These are not errors. So all of this about the conflicts and all of that, perfectly fine. There's a difference between a warning and an error. A warning means here's something you need to be aware of, possibly. Error means it just didn't work. So that worked. So that needs to go in the script. The next thing we need to do is create an object with the name of with the address, the web address where we're going to find the data. And so I'm going to name this URL, which is actually the technical name for a web address. So that's why I'm calling it URL. And I have recommended not copying and pasting, but since this is so long, you've got to be careful about, you would have a real chance of having a typo. So you can copy and paste that web address. Make sure that the quotation marks are right. So you should type the quotation marks, but you can copy and paste the web address. Don't copy those quotation marks. You'll get an error, but you can copy the address. The next thing we're going to do is we want to create a data frame to hold this. And so we're going to call it Gapminder data. And then we're going to use a function. So before we used a function read period CSV, we're not going to use that because this isn't a CSV, it's a TSV. And that's why we needed the tidyverse, because that is a tidyverse function. Why do we need that? Because this file is in a what's called a tab delimited format. The other is comma delimited, CSV. Just means that the columns in the file are separated by tabs instead of columns. So we're using read TSV. If the internet cooperates, I can highlight that. I can highlight this. Actually, I need to do this first. So I need to make sure that is done. And then I can highlight this and run it. And it actually went pretty quickly. I've had that take a while before because you never know what's going to happen with the internet. So now it's out there. 1,700 observations of 6 variables. Let's go see what those observations are. We use the view command to view the Gapminder data, and there it is. We've got countries, years, continents, life expectancy, population, and GDP per capita. So life expectancy, population, GDP per capita, and the unit of observation here is the country year. The continent is just another variable. So the real variables here are continent, life expectancy, population, and GDP per capita. Country year is the unit of observation. So if you have the data loaded and you want to really explore it, because there's a lot more there than there is in this one, you want to start doing some things with it. One of the first things you were going to want to do, again, is get yourself a nice little list of the column names that you can work with. And then you can go in, and so you can find the mean, median, variance, or standard deviation for at least one variable. Do that. I'm not going to show you how to do that. I am going to warn you, you can't find the mean, median, or variance of country or continent because those are categorical nominal variables, and you can't find means or medians of nominal variables. But you can for any of the others. So you can pick at least one variable and find that, and then you are done. And I am done because I'm not going to show you how to do that. But after you do that, come down here and select everything in this, and copy it and put it in a file and submit it in Canvas. I think the assignment is already ready. If it's not, it will be in about 15 minutes. It'll be ready before the end of the class period for today. So that is it for this lab. I will hopefully see you all in person next week. So thank you, and I will see you all later. Bye.